Moving on to the second problem on the concept solids resting on slant edges or triangular faces. So this is the second example. Here the problem statement is as follows: a hexagonal pyramid 25 mm sides of base and 50 mm axis length rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. So here the example is with respect to the slant triangular faces, one of the slant triangular faces on which the pyramid is going to rest. So initially when you start with the problem, solving the problem, first I've considered an hexagonal pyramid. So first I'll draw the hexagon in its top view. How do I draw this? It has to be resting on the edge position. Okay, you cannot go for a corner position in this case, because if you go for a corner position, then it becomes the slant edge on which it will be resting. But if you want to get it placed on a triangular face, it has to be the base position. Okay, we have seen in the previous example, it was the corner position that is how you rest the pentagon on, and only then you can move it ahead with respect to the pentagon resting on the slant edge. And in with respect to a pentagon resting on its triangular face, it has to be always rested on the edge position. You take either this side or you take either this side, accordingly this is going to change. Now I have considered this, therefore this pyramid is going to be turned in this direction. Suppose if I consider this as the triangular face, that is O F1 A1, this will be positioned in the other way. Okay, so here just for your better understanding, I have marked the triangular face with red pen. So once you get the top view, you project it up to get the front view. Front view here, actually if you see this edge OB1, it will be hidden, but as it is overlapped by this edge OE1, it has to be shown as a visible line and not as a hidden line. So once you get this, you have to move this triangle in such a way that it will rest on its triangular face. So actually this is the triangular face that is there along this line, which is not visible as a triangular face but just as a straight line because it's in the front view. So this is the triangular face which has to be on which the pyramid has to rest. So first, how do you transfer this now? It is O dash, D1 dash, C1 dash that you have to measure, and you mark it on this XY line such that that triangular face O dash, C1 dash, D1 dash, O dash, C1 dash, D1 dash, which is visible as a straight line, but actually it's a triangular face. You can see O, C dash, D1 dash. You first draw this, measure it with a scale and draw this. Then with the help of a compass, you measure D1 C1 dash to F1 A1 dash and mark it here, mark an arc here. Then you measure O dash F1 dash A1 dash and with the help of compass place it here and you cut another arc. You get a point of intersection, then you join this. You see where is O1 dash, E1 dash, B1 dash, and you mark it here to get this view. Okay, such that it is resting on its triangular face. Then you just have to go for all the projections, project them in order to get the point of intersections, which will be labeled as the points of the or the corners of the pyramids. Once you do this, follow the rules of visibility. First, join all the outlines that you see here. After you join the outlines, observe this face is visible. Yes, therefore you'll show the hexagonal base as visible. All the edges that pass by it will be shown as hidden and those remaining will be shown as visible. Next, it is said that draw the projection of the pyramid when the axis is inclined to VP at 45. It's not said that it appears to be inclined, therefore you have to go by locus method. How do you go by locus method? First you draw a 45 degrees line. Then you see what is the true length of the axis, that is 50 mm. You mark that, and then with this new axis length, that is O1, you have to cut an arc to get the locus of that axis, and then with the help of the box method, you transfer this thing here. These type of locus method problems we have already solved in the class, so you just have to transfer it by locus method. You have to transfer this thing here. Once you complete this, then again go for all the vertical and horizontal projections such that you get all the point of intersections, label them and complete the final view. In order to get this, first go by the rules of visibility, join all the outlines, once you complete the outlines, then you see whether the base is visible. Yes, it is visible, so you show the base as visible. The edges that pass by the base will be shown as hidden, that is A1O, B1O, and the remaining edges will be shown as visible. So this is an example on projection of solids when the pyramid is resting on its triangular face.